Hello, everyone. I am not the last presentation between you and drinks. I'm just probably the second to last presentation between you and the reception. So my name's Lynn Comp. I am a server technology marketing vice president at AMD. And we're going to talk about what makes EPYC so epic and why sustainability is critical. We've talked about that all day, but also can't forget about security. So one of the things that we have heard quite a bit about is optimal solutions. What is the right approach? What is the right mix for general purpose cloud and for cloud native development? And I've had most of my career started out in handsets, base stations, and risk processing. And then I spent the rest of my career at Intel and now AMD. What was really interesting is I asked one of the micro architects for the first ARM processor that broke, this is going to date me, that broke the 100 megahertz barrier for processors of that category. I asked him, which is better, RISC or CISC, and how did you make this break that megahertz barrier? And it was really surprising because he was originally an alpha architect, if you remember the big iron that digital was bringing out into the market in the 90s. His comment was, it doesn't really matter if it's RISC or CISC, it's all in the physics of the implementation, because whether you're going to execute 1,000 instructions or whether you're going to execute 100 instructions, software is software, you're still executing the same program. So one of the things that EPYC has managed to do is break a number of assumptions and barriers in terms of how do you get scalable performance, how do you optimize workloads per watt. Performance per watt is cute, it's nice, it's a metric we all know if we are in silicon, but you'll see that a lot of companies who are having to deliver solutions and implement data centers and grapple with what it means to try and get power to a data center in a county that happens to have one of the major interconnects between the US and Europe that is not going to give you more power. So what do? You have more density that you have to go after. So there's a lot of different innovations across the board, and some of it, quite frankly, is what's old is new again when it comes to practices that used to be common. We got away from it in the industry, and now they're starting to come back in. And then not to be forgotten is security. I was in Europe at a data center event last month and talked a lot about energy and workloads per watt and efficiency. And I had a number of people take me aside and say, in this market, the reality is security is more important than even energy, which really surprised me because in the US, there's a little bit of a habit around access to less expensive power. But in Europe, it was a big surprise to me that security was really top of mind to the extent that it would take precedence over sustainability and energy efficiency. So first of all, let's talk about scalability, scale out, if you will. Faster business insights, more customer transactions. When I ask people, why does performance matter in the cloud? Most people who have run SaaS applications, they know the answer. It's either one or both of paying less money, because performance isn't exactly a race to idle when you're running cloud services. It is a race to shut down the VM that you've just initiated or instantiated, because you want to get your work done and stop paying some of the margin back to the cloud service provider and get paid for your own software. More customer transactions, the best example that I can give for this is Alibaba Singles Day, 11/11, or Black Monday, or Black Friday. So number of sessions that you can have closed quickly and efficiently, that equates to top of line revenue. So performance matters for both bottom line as profitability and margin. It also matters for top of line revenue. So performance and scale. Let's talk about consolidation and infrastructure benefits. We've had a lot of math around the number of servers and the number of racks for performance. But this is just one comparison that we did. This is 4th generation AMD EPYC, it's codenamed Genoa, and the Intel Platinum Ice Lake. You might ask why we're not talking about Sapphire Rapids. Predominantly because the install base in question is more Ice Lake than Sapphire. So consolidation benefits, 15 servers to 5 servers to get the same performance, the same work, the same amount of workloads implemented, and yet you have 67% fewer servers, half the power, a significant CapEx reduction, and a pretty significant OpEx reduction. So there had been a statement earlier this morning by one of the presenters, the gentleman from Broadcom, who said you could probably pay for your power savings by upgrading old infrastructure, and it really is true. I know it sounds kind of convenient coming from a hardware provider, but at the same time, where power is becoming increasingly important, and you still have to be able to serve the same number of customers, it really is important to be able to have more work done in less space. Now, one thing that I wanted to make sure everybody was aware of is AMD took an energy efficiency goal in 2020. And it was really, we need to get 30x better on energy efficiency by 2025. And you can see that we've mapped out the curve here. And we actually have a bend in the curve, which means we're ahead of that 30x curve, what would be typically mapped. And a lot of that is because of the innovation that's gone into EPYC 4, into chiplets, and into the technologies that are a part of delivering EPYC with our partners. So this is a funny analogy to use in Europe, because I don't think Europe has seen 4 million acres of forest in a while. But if energy efficiency was measured in acres of forest, 1 million Intel servers versus 300,000 AMD Genoa-based servers, you end up with 7.3 billion kilowatt hours saved, 3.7 million tons of carbon dioxide emissions saved, and about 4 million acres of tree. If you're curious on how we did this calculation, it's a handy-dandy EPA calculator. I can send you the link. So EPYC CPUs, let's just talk a little bit more about what this translates into. And really, this is a lot of text. All you have to see is the bottom row. Rack energy efficiency, so watts per vCPU. Essentially, you can get about 44% better energy efficiency out of having your instances on EPYC versus the same instance running on a different processor architecture. So again, there's a lot of different ways that you can solve the energy efficiency problem, and this is one really important one. Now, I am going to give you a little bit of a riddle, and I know it's hard because I can't see anybody, and you're probably not going to talk back at me, but when I was working on StrongArm, and I was an applications engineer helping get StrongArm designed into handsets, we had an interesting dynamic where we were constantly hearing, your TDP is too high, your TDP is too high, your frequency is too high, your battery life is not going to be as good. And in reality, it turned out that compared to processors that ran at a slower frequency and had lower TDP, the battery life turned out almost twice as good with the higher TDP processor and the higher frequency. Does anybody know the 3 words of why that is the case? Called race to idle. That's battery life. Let's talk about operations per watt, or work accomplished for power used. One of the things that you will find AMD believes in is no watt should be wasted. You should get maximum amount of work from every watt that you spend. And energy consumption is defined, this is just high school physics, the production of a certain amount of power for a certain amount of time. The analogy that you will see on sustainability websites about energy consumption is a 150-watt light bulb versus 60-watt light bulb, and you need so many lumens to achieve that. You're going to have better efficiency out of the 150 watts, even though its label says that it is driving more power. So this is just public results that's published at Spec Power. Just pulled it down and put it in a graph. And you can see that when it comes to how much work can you get done for every watt you spend, Genoa, despite having a higher TDP, turns out to be significantly more efficient than other architectures. And so depending on whether you're looking at what was published on ARM-based architectures or what has been published about other x86 implementations, you're talking somewhere between nearly 60% or sometimes up to 4 times as much work per watt. Again, you have to think about how much work can I get done for the budget I have, and this budget is watts. So this is actually just a really rough illustration that explains this dynamic, and it's all hypothetical math. If you want to get 12.5 million Java operations done, and you are capping at a 70% operational loading. Why 70%? Because a lot of enterprises will cap it at 50 to 60%. There are some cloud service providers who I've heard will occasionally go up to 80 or 85%, kind of right on the edge. So what you can see is that essentially to run something at a 70% load and idle power is 67-ish watts, you can see that you have to run just 1 1/3 cycle to be able to accomplish that amount of work. If you're running a lower TDP processor, but you're not able to get as many instructions or as much work done, you'll find that you have to run longer, and then you go back to idle. And device physics wins every time. When you're in idle, in general, it happens to tie more to the process node than it does to the processor architecture. And whether you are running in a handset, a base station, or you're running in a data center, there are times where you are not drawing active power because of the way that follow the sun works. And despite all of the attempts to get us to use as much compute power at 2 a.m. as we possibly can, you will still have a lot of the data center that is not necessarily doing its full utilization at a given point as people go through their normal work days. So we've had customers who tell us they see this as well. You can see that Cloudflare has a really interesting dynamic or metric. It's called requests per watt. I think that the industry as a whole will really do ourselves a favor if we start talking about workloads per watt, because that is much closer to the essence of how much work can I get done for every watt of power that this thing consumes than performance per watt. It's a handy, quick rule of thumb, but really it's workloads per watt, and that workload and the utilization has everything to do with the efficiency that can be gained out of a given solution. You can see Lobster Logistics is another one, and Nokia saw a significant bump in both performance and a significant reduction at the same time in the amount of power that they had to invest to be able to deliver a networking solution on EPYC processors. So back to security. Security is really, really important, and especially, I think, one of the best areas in the world that understands the importance of privacy, data privacy, maintaining keys, having the businesses have integrity. It is in Europe. And so wanted to go through the advanced security features of AMD EPYC. It's encrypting data while it's being processed, in use, in motion. And then we have healthcare companies, financials, as well as telecommunications companies that are effectively running their operations on top of cloud service providers who have these features implemented right now in their clouds so that the customers can maintain their keys. Like, the cloud operator never sees the keys. They have no idea. They can't get into what is being transmitted. It is completely private with whoever is using that particular service. So we have a number of these solutions that are powered by AMD Cloud. These are all available on our website. But again, when you go to AMD EPYC, it is one of the most efficient. It is going to be one of the most cost-effective. And You'll have happy customers because the performance is great. And we have a large ecosystem. Many people have said that, but many of them are here. You can talk to them about how fun it is to run on the AMD EPYC processors. So with that, I'm over by 7 seconds. Thank you very much.